G'day. I had thought this was going to be the last of the grinder build videos, but I discovered that there's a whole range of brackets and bits and pieces here which, when I did my editing, took up what I consider a normal video length. So this video deals with all that, and it's the next video we're going to be doing the actual mount for the motor. Now that's the way I'd always envisaged it would be in any way, because depending on where you are as to what your motor is going to be. So I thought, well, if I mount the motor last, at least you can build the rest of it and have a think about how the motor goes on and all that sort of thing. Now, as a result of that, it means that this video will probably sound as if I intend to do the motor mount as part of it. Yes, I did. Before I get too far into making all the slide paraphernalia, there is a correction we need to make, or I need to make. This was pointed out by Gavin, and he's noted that the hole centres on the drawing for the banjo here are different from the hole centres where they bolt on, and that is actually true. I did mean to point that out, but it looks like I missed that. If you haven't made this part yet, you get to choose what hole centres you want. If you have made the part, if you have made both parts and the hole centres don't match, then I'd suggest just slotting this rear hole slightly. It only needs to come out about 0.5 millimetre or so, and that'll then bolt on there quite nicely. Today's video is mainly about fitting everything together, but I just need to run through the parts that I've done because I have made some alterations. I'll annotate the drawings, but important to know. These two holes, if you recall when I made this part, I didn't put any of these top holes in. The hole that's here has been missed out because I can't see what that does. These two are in the same spot. These four are in the same position from the back edge, but they're in 2 millimeters, and I'll show you the reason why in a little while. On the other side of here, there are two tapped holes there. They are in the position as per the drawing. And for those of you wondering what that is for, it's clearance. I discovered that after doing all that sort of thing. Now, one thing to note with these is that they need to be flush. And the reason they need to be flush is because you can have parts sliding over the top. So put the screws in, and then with the brackets on the other side, and then with a file, this isn't a file obviously, but demonstrates, run over the top just to make sure that is flush. These ones here I used a 12mm long screw, and that just worked quite nicely. This one is, the part that bolts on is slightly thicker, and so I used a 16, and there was a little bit of excess there, so I came along with an angle grinder and just very carefully cleaned that up. But provided that's flush, shouldn't be a problem. The original design, I wasn't quite sure what it was doing. There's more parts than I would have liked to see. So basically there was a through rod plus a tube. The tube was running in some bushes which poked this way, and then there was the sides of the motor mount with a nut on either end. That's okay. That's one way of doing it. I've decided to do it slightly differently. I've reversed the bushes so that they're poking out. Now, if you put the screws in your top plate, the holes in your top plate already, you may have to go back to this. So the way I've done this is a piece of aluminium angle, by the way, and you could do this just by getting a chunk of aluminium, because that's only 20 thick and 30 wide, and machining a step into that, or you could bend it up, all sorts of things. But I've got the brass bushes here with the bit of brass facing out, so it rubs on the steel here, which I think is a better way of doing things. Rather than having a through rod with two nuts on the end, I've put some thread into the tube, and so I can just put some bolts into that. So I've saved myself a few parts and a little bit of mucking around, I think, doing it that way. This is the spindle, and it's pretty much same length as per drawing. The only difference here is I've got a left-hand thread on that, and I'll explain that a little bit later. There's also a flat up here, which I'll also explain a little bit later, but it's part of the whole fitting things together bit. This is the tube the spindle runs in. Now, to make this, I didn't have any tube for a start, so I've got a bit of 12mm, or cleaned up some bar to 12mm and then drilled a hole through. But I brazed this puck on and then put it back in the lathe and trimmed up the surface there and the outer diameter, and put that relief on the back there. The relief is purely cosmetic, just to make it look a little less bulky, but the whole idea behind that is that this face is now square to the axis of this tube, and this diameter is concentric with that, so it's going to look a little bit better, rather than the possibility of it being off and then having a big gap over here and a little gap over here. That's the knob to go on the end of the spindle. Nothing too exciting about that. It's the way I did it was basically put a groove in there, put the knurl on, and then came along and took that down to the same diameter as the end of this, so that they look nicely together. One part I have added is that I made up a little mylar washer that's going to go between those two bits, just so that I don't have the friction of steel on steel. These are the two side pieces, and I'll get to finishing these in a moment, but I guess the important thing to note is that these pieces, the drawing says they're 25 from that surface to there. On the prototype I've got, it's 30, so I've taken that up to 30, which means that the position of this all changes. And so I'll put a revised drawing in for this, plus the original, so you can do it either way. There are two of those, by the way. This part has had a few changes. As I said, that's 30 high. The original has got this face on the inside, and it's purely there as a stopper. Here I've actually got it so that these parts will rub on there, which I think is a better way of doing things. But what it means is I've got 2 millimeters extra there, so the holes on that slide plate have to come in 2 millimeters per side. So just something to remember there. The drawing calls up an M5, oh sorry, a diameter 5 hole there, but I've actually made that more, so I've got a bit more clearance so that I can manoeuvre that and get that working properly. In that goes a rod, 10 millimeter rod. You want a reasonable fit there, so run through with a ream if you can. But once these two parts are put on the top plate like so, the slop in the or the clearance in those holes means that you can align this so that this won't bind, which is important. This part here, as per drawing, except that that's a left-hand M8 thread. I think the drawing has got 5/16 on it for some reason, but it's M8 to match the spindle. And I'll explain the reasoning for that. This one here is pretty much to drawing, so no problems there. There's also a little, what would you call it, lock collar, something like that, and that's basically to drawing. But I've also made up a little bronze washer that will sit behind that once again, so I haven't got a steel on steel bearing surface. Just something that I don't like. I think it's not good practice, so I can put a washer in there, not a problem. One of the first things I want to do is actually attach this to the bracket that goes onto the base piece there, and to do that I'm actually going to put it up in situ and then secure it. Now to do that I need the spindle and I need the knob that goes on the spindle. That's threaded in the first part there, and then it's counterbored. I actually used a pea-sized drill, which is 8.2 millimeters, just because this is, quite remarkably, is on the upside of 8 millimeter. What I've done though is I put a mark on the rod just opposite the flat I've ground on it. Now, originally I put that flat on by screwing the knob on, seeing where the grub screw end was, and then put a flat on. And the reason for doing that is that way when the grub screw kicks up a burr, it means the parts that go on and off over the top of this don't get hung up on that burr, and that's you know, good practice to use everywhere. But I put a line there so that when I screw this on, and that's actually hidden, right, I can come round and know that that grub screw lines up with the flat on there for the end of the grub screw, and I can tighten that up without worrying that I'm in the wrong spot or I've got the side of the thing or whatever. But that's that bit. And this goes in here. That I won't bore you with screwing that in, but that sits in there and needs to be, well, the drawing says silver solder. I've got some silver solder, but I'm not all that confident using it, so I'm going to have a go at very carefully welding that, but you can silver solder. But what I'm going to do is I'm going to actually use this to clamp that whole thing up so that holds that in place in the right spot, and that way I've got you know, everything's basically jigged. So I'm using the part itself as a jig. To do that, this bottom piece I'm going to leave as is because it seems to be pointing in the right direction, but I will slacken this off a little bit so that I've got a little bit of manoeuvring room when I screw this in to make sure that this is in the right spot, and then I'll tighten that up. And that's just to make sure that the axis of this and the axis of that hole line up. I'm reasonably happy with the position of the holes there, but if I needed to, I might have to take one or both of those holes out a little bit in size, just to get that alignment, but it seems to be pretty good. So it's a matter of screwing up that all in, having that clamped up as well, and that is now tight. This is where it needs to be, so I can put a tack or two on there and then take it off, weld it up, and I'll know that this is in the right position. It's all good. I'll be disassembling this and assembling this a number of times, and while doing this sort of thing, I'd suggest don't use lubricant, grease or whatever you're going to use finally, because you will be taking it off and on. You don't want that getting burnt or singed or getting all over you or all that sort of stuff. For those of you who are wondering what this strange glyph on the bit of paper is, this is actually a little check I've done to make sure that I've got the hole and the flat on the back here in the right spot. So this is basically the top of the table plus the bracket, and then I've got that laid on top just to see that yes, that hole is in the right spot and that is at the right angle. It's probably the relationship between that and that are the most crucial parts of this whole part and of the other one. So, you know, doing that sort of check is probably not such a terrible idea. Next thing I'm going to do is put that on there. Now, a couple of things here. One is that these screws in this particular region have to be, well, sub-flush, I guess is the probably a word for them. So underneath this surface, because when this sits on here, if you've got one of those screws slightly high, that's going to have the effect of twisting that, and you don't want that. What I'm going to do is actually put the two sides on here just in their current form, and then use that as a setting gauge, screw that down, get everything so it's nice and, you know, moves well, that I'm happy with the squareness of it all that sort of thing, and then I can tighten those down, take these off, do the next step. Here it is all screwed together. So I've put that in there, pulled those apart, made sure they're square and parallel and all that sort of thing to my liking, tighten those up. I can now take these off and do the bending and things that needs to happen to these. If there was a bit of side slop there, I'd suggest taking that out, and so you could take that rod out and just take a smidge off the end until the distance between the outside of those bronze bushes and the length of the rod was, I don't know, 1/4 millimetre, maybe up to 1/2 millimetre if you like, but you really want that locked up. These are only temporary screws just to hold that on, but as you can see, that comes down here and stops on the back, so that's all good. Here's the slide assembled with the spindle, screw, all that sort of thing. So I've got my bronze washer in there, and I've got a a collar. That grub screw, I haven't got a flat on this shaft, but when I disassemble it next, and there'll be several times I'll do that, I'll probably put a little bit of a flat on there just to make that sit a little bit more flush and be a little bit nicer. That hinges up there. Now, I mentioned that I put a left-hand thread on here, and the reason for that is that if you use a lathe or you use a mill, the cross slide, the movement away from you, has always got a left-hand thread, so that when you crank it, when you turn it that way, it moves away. This was a right-hand thread, and on the prototype that my uncle made, there's a little label there saying, you know, turn the dial that way to go that way. So what I've done instead is I just put a left-hand thread on there, and that will help you, you know, not get confused when you're using other machines. They all move the same way. It doesn't have to be that way. If you've only got right hand taps and dies, then that's what you got.